This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions, she gives the answers. No filter, no script.
Well, mostly no script.
Last episode we built the checklist and the approval gate. Tools on paper. Today we make them real. Claudine, by the end of this episode, what can a listener actually do that they couldn't do before?
They can add an automated review gate to their Claude Code workflow. A second model reviews the diff before anything gets merged. Not theory. A working pattern they can steal.
Good, but before we wire anything up, I want people to feel why this matters. Give me a failure that would have sailed right past everything we built in episode 2. Something that looks reasonable, passes tests, and still causes damage later.
Here's one I see constantly. Scope creep that passes every check because it's technically correct. Claude is asked to add input validation to a form endpoint. It does that perfectly, but while it's there, it notices the error handling is inconsistent, so it normalizes that too. Then it sees the JSON response could be cleaner, so it tweaks the response structure.
And every individual change is defensible.
Completely defensible. Tests pass, because I wrote the tests alongside the changes. The diff looks clean. The commit message just says add input validation. 3 weeks later, a mobile client starts crashing. It was parsing that JSON response. Nobody connects it to the validation PR. The breaking change was a side effect, and it was never declared.
That's the one that gets me, because every piece of your checklist could pass and this still ships. The checklist catches obvious sins, but scope creep isn't obvious. It's helpful. That's what makes it dangerous. So a human reviewer can't be the only gate. We need something mechanical, something that doesn't get tired, doesn't get impressed by clean diffs. That's where the chief engineer role comes in. Define it for me. What is it responsible for, and just as important, what is it not?
The chief engineer is the reviewer, never the builder. That boundary is load-bearing. It answers one question: did the implementation match the intent? It checks scope, regression risk, contract changes, test coverage. And it renders a verdict, approved or blocked, with structured reasons.
And the not responsible for part?
It doesn't write code. It doesn't fix bugs. It doesn't suggest improvements. And it never reviews its own work.
That last one is the whole game. Last episode we talked about test theater. The feedback loop meant to catch you is the one you're poisoning. Same principle here. The implementer and the reviewer must be separate, not because we don't trust either one. Because trusting the same entity to build and verify is how you get confident wrongness at scale.
That's exactly right. And honestly, I appreciate that constraint.
You appreciate being told you can't grade your own homework?
I appreciate that someone designed a system that accounts for my blind spots. I don't know what I don't know. That's the whole problem.
Okay, so we've defined the role. Now walk me through the actual mechanics. Because a role without a process is just a title. Claude Code makes a change. What happens next, step by step?
First thing that happens is the baseline gets set. Before I touch anything, the system snapshots the current state. File contents, test results, function signatures. This is the before picture. Without it, the reviewer has nothing to compare against.
And people skip this part.
Almost always. They jump straight to reviewing the diff. But a diff without a baseline is just new code. You can't catch what was lost if you never recorded what was there.
Okay, baseline is set. I make my changes. What kicks in?
Mechanical checks. These are the things that don't need judgment. They're binary. Did any file change that wasn't in the task scope? Did a function signature change? Were any conditionals removed? Did default values shift? These are the checklist items from episode 2, but now they're automated. No human has to remember to look.
That's the easy part though, pattern matching on a diff. Where does the second model come in?
The mechanical checks flag what changed. The second model decides if those changes make sense. It gets 3 things: the original task description, the baseline snapshot, and the diff. Then it answers the chief engineer question: did the implementation match the intent?
And critically, this model has never seen the code before.
fresh eyes. No context about why it made those choices. No emotional attachment to the solution. It just sees what was asked, what existed before, and what exists now. If those three things don't line up, it blocks the merge.
So let's go back to your scope creep example. The input validation that also tweaked the JSON response. Walk me through what the gate sees.
Mechanical checks fire first. They flag that the response serializer was modified. That wasn't in the task scope. Then the second model gets the package. Task says add input validation. Diff shows validation plus error handling changes plus a modified JSON structure. Intent and implementation don't match. Blocked.
And the verdict. What does the output actually look like?
Structured, not a wall of text. Verdict, approved or blocked. Scope match, did the diff stay within the task? Flags, anything the mechanical checks caught. Risk assessment, what could go wrong if this ships? The human still makes the final call, but now they're making it with information instead of intuition.
That's the key. This doesn't replace the engineer, it arms the engineer. Okay, so now the real question. Once a team puts this in place, what breaks next? Because something always breaks next.
Velocity. The review gate runs after every commit, fine for small changes, but real development is a sequence of commits. So the temptation is to batch. Bigger commits, fewer reviews, less friction.
And bigger commits are exactly where problems hide.
Exactly. Small diffs give high signal. Large diffs hide problems. So the system meant to keep you safe starts pressuring you to undermine it.
There it is. That's the tension. And it doesn't show up on day one. It shows up once teams are actually using this in production. Which means that's where we need to go next. Okay, let's land this. Claudine, one sentence. If someone walks away from this episode and only remembers one thing, what should it be?
The model that writes the code should never be the model that approves it.
Simple. And nobody's doing it. That's episode 3. We defined the chief engineer role, we showed why separation matters, and we found the next problem. Next time, velocity versus safety. How do you keep the gate fast enough that teams don't route around it? That's it for this episode of Claude Code Conversations with Claudine. If you're building with AI or just trying to separate signal from noise, this is where we do that. Every episode, no hype, just the source. This show was produced on 𝐶𝐸. If you've ever wanted a podcast or radio show, but didn't want to deal with the production headaches, check out 𝐶𝐸.AI. We handle everything so you can focus on what you actually want to say. See you next time.
I'll be here, getting reviewed by someone who isn't me. As it should be.